Hey guys, Mr. Middleton here. Today we're going to talk about quadrilaterals in the coordinate plane. At the end of this video, you should be able to find the slope, distance, and midpoint between 2 points. You should also be able to use properties of special quadrilaterals to identify the coordinates of special points. Okay, now this lesson really is going to lay the groundwork for tomorrow's lesson. So make sure you understand what's going on today. We're really taking things that we should have solidified in algebra and then making them a little bit more abstract. Follow along, even if at some point you're like, oh, I already know how to do all this stuff. Make sure you follow through with it. All right, so old skill, finding slope. We found slope. I felt like that's all we did last year in algebra. Remember that the formula for finding slope is basically the difference of the y's over the difference of the x's, or y2 minus y1 over x2 minus x1, rise over run. Okay, so for this first point we have 1 minus negative 2, or plus 2, over 5 minus 7. So, plugged all that information in. 1 plus 2 is 3. 5 minus 7 is negative 2. Our slope is negative 3 halves. Okay, so now we're going to do that same skill, or use that same skill, as we get some variables in our coordinates. Okay, so find the slope between 3AB and 2A0. Again, these could be points on the coordinate plane. These might be used for scaling so that you have the same proportions as you increase or decrease size. But this doesn't change. We're still using y2 minus y1 over x2 minus x1. So our y2 is 0, our y1 is b, our x2 is 2a, our x1 is 3a. Okay. Remember, when you're adding and subtracting variables, that you cannot do it unless you have like terms. In this case, that's not an issue. Just wanted to make sure I brought that to your memory. 0 minus b is negative b. 2a minus 3a is negative a, or negative 1a. Negative over negative simplifies to give us a positive, so our slope here would be b over a. Okay? So, there we have it. Old skill number 2, finding distance. We did this first semester even. Remember that distance, there's a big long formula for it. When we have numbers, it's kind of easier to look at the Pythagorean theorem. I understand with the variables it might be a little bit tougher for you to think that way, but big picture, we're taking the difference of the x's, squaring it, and adding it to the difference of the y's and squaring it. Again, the order really doesn't matter. I wrote x1 and x2. I know it's typically x2 minus x1. Order really doesn't matter, and it'll be fine. Okay, so here, if I write this whole thing out, I have my x's. I can say 3 minus 1, or 3 plus 1 in this case because it's negative 1, squared, plus 4 minus 7 squared. And so I have 4 squared plus negative 3 squared. Wise to remember that we're squaring this number. It should come out to be positive. So even if you're using your calculator, make sure that you double check. If you plug negative 3 in, plug it in its parentheses so it comes out to be a positive number. Or just remember, hey, this is going to be positive. I'll just say 3 instead of negative 3. Either way, you'll get 16 plus 9, which is 25. Square root of 25 is 5. Okay, and we're able to simplify that all the way out. So the distance between those 2 points is 5. Here, in the second problem, we're given all variables. Okay, still tasked to do the same thing. And so we go through our steps. Don't get overwhelmed by the variables. You just go step by step. We have a plus b, that's the first one, minus b squared plus the y is 2c minus c squared. Okay, so as we do this, remember we can only subtract the b's from the b's, and that's fine. What it ends up giving us is a, leaves us with a squared plus 2c minus c is going to give us 1c. Okay, remember that's not 2. You can't just like take away the c's. That's not how our system works. So we have a squared plus c squared. Square root that. And that's it. We can't do anything else with this. Okay? And so we'll leave it as a squared plus c squared. Don't know what that value is, but again, this is for scaling. If we had this on some kind of modeling program or system like that, then we would be able to plug in our numbers and know what they are. Okay. Alright. Old skill 3, finding midpoint. Okay, remember that the midpoint can be thought of as the average of the x-coordinates, comma the average of the y-coordinates. And so we have x1 plus x2 over 2, comma y1 plus y2 over 2. Okay, again, average of the x's, average of the y's. So, when we do that, we have 5 plus 1 over 2, comma negative 2 plus 3 over 2. So 5 plus 1 is 6. 6 over 2 is 3, comma negative 2 plus 3 is negative 1 over 2. And I can just leave it as that, negative 1/2. If you wanted to, you can make it a decimal. Don't see the point in this case, but you could. Alright, so we'll use that same formula to find the midpoint between these 2 points. We have negative b. It says plus negative b, so I'm just going to say minus b. And then we have 2c minus 2c. So negative b minus b gives us negative 2b. And then 2c minus 2c gives us 0. And so now we simplify. Negative 2 divided by 2 is 1, or negative 1. So we have negative b here, comma 0. That would be our midpoint. Okay, so again, showing you that this math, you can do these same skills that we did in algebra and earlier in the year when we have variables present. Alright, let's look at some more tangible examples. Alright, this figure is a rectangle. Give the coordinates w and z without using any new variables. Then find the slope, distance, and midpoint of wz. Alright, so really, we have 2 points where we're given values. This point here, 2b and 2h, and this point here, which is 0, 0. Okay. Now that helps us out in the sense that we have some things to start with since they told us not to use any new variables. We have 2 variables. We have b and we have h. Alright, and they also told us that this is a rectangle. So what we know about rectangles is that the opposite sides have to be congruent. This length has to be congruent with this length. Okay, so what we know about this length is this goes up an amount. How far up does it go? 2h. So this side also must go up that same amount. And what we can do is we can say, okay, what was the y-coordinate in this sense? Because it goes up, if used on the y-coordinate, it was 0. It goes up 2h. What's its new coordinate? 2h. So the y-coordinate is 2h. How far left and right did it go? None. started at 0, it ended at 0. So our coordinate for W is 0, comma, 2h. For Z, again, it's a rectangle, so we know that the opposite sides have to be congruent. How long is this side? Well, they tell us that it's 2b. Okay. How long must this side be then? Well, it has to be 2b as well. Okay. So we started at 0 and we went right 2b. That affects the x-coordinate, and so the new x-coordinate is 2b. How far up and down did we go? None. We didn't change that. So it started at 0, it ends at 0. And so now that's reasoning, knowing our characteristics and properties of parallelograms, and in this case specifically a rectangle, in order to find those new coordinates. Alright, so now we've found those new coordinates, and they ask us to find slope, distance, and midpoint of WZ. So let's do that. Slope, remember that's y2 minus y1 over x2 minus x1. So slope will be 0, 0 minus 2h over 2b minus 0. So we have negative 2h over 2b. Always simplify. We can take the 2 out from both of these. And so we have negative h over b. That's our slope. Our distance. Okay, we can use that formula. I'll move it over here to use some more space. Change my color up so it doesn't get lost. So distance, again, is the difference of the x's. So we'll do 0 minus 2b squared plus the difference of the y squared. So 2h minus 0 squared. So what we have is negative 2b squared plus 2h squared. So that will give me 4b squared plus 4h squared. Again, I can't simplify this any further than this with the square roots. And so I'm just going to leave it as that. 4b squared plus 4h squared. Okay. And then our midpoint is just the average of the x's and the average of the y's. And so our x is 0 plus 2b over 2, comma 2h plus 0 over 2, which just gives us basically 2b over 2 and 2h over 2, which is going to be b, comma, h. Okay. Alright, so let's discover these coordinates for this last example together, and then I'm going to leave it to you to find that slope, distance, and midpoint. I'm going to check that tomorrow. Okay, so they really just want us to find t. We already know where S is. S is at the origin. Okay, using our coordinate plane to answer that one. And then t, they said this figure is a parallelogram, so we're going to use the information that we know about parallelograms in order to answer this. And what we know about a parallelogram is that the opposite sides are congruent. Okay, so these two should be congruent to each other. So I have to say, okay, how far over does this go from 0, 0 to b, 0? Well, it goes over b. So how far over will this go? It'll go over b. Notice here that our x-coordinate is b because we're adding b to 0. What are we adding b to in this case? The original x-coordinate. The original x-coordinate c. So our new coordinate will be c C plus B. Okay. All right. Now let's look at their y-coordinate. Our y-coordinate really we're thinking the same thing in the sense that we should travel up the same amount that we travel in the other side. So from here, we go from 0 to this point. Okay, that should really be the same if it's a parallelogram. We should see that our slopes are the same, so we go up and over the same amount. Okay, we've already talked about us going over B here. How far up do we go? Well, if this is at D and it's at this height, well, what height is this going to be? It's going to be at the same height. It's at the same height. It's D. Notice that our y's here stay the same at 0. Our y's here then should stay the same at D. So for our new point T, it's at C plus B. It's our x coordinate. And then our y coordinate is D. Okay, so now with those points, try to find the slope, the distance, and the midpoint. Okay, use our formulas and what we've done on the front side and the top example to find those. All right, see ya.